Here's the SolOhm board I'm doing some software development for today. I have it powered on a LiPo battery, and I have a single pass transistor over here. This is the activity light, this blue one here, and the day sensor is over here. I have a couple of scope probes plugged in. This one is measuring the panel voltage, and this one's measuring the panel current. This power supply is acting like my panel today, and we're sitting right around 15 volts. And this is my series resistance. It's a AC heater, but I'm just using it as a load resistor. It turns out it's about 5 ohms. I got it hooked up to my scope up here. And what I have running now is a couple of things. I'll type in the IP address. So what we have over here is, here's the uptime. This thing's been running for 1800 seconds. V panel is about 15.9 volts. I panel is 0 because it's the load resistor is open. Then there's three batteries in that LiPo pack, and this is the combo system voltage is 11.8 or 11.5, and then here are the individual cells, and then here's the day sensor. So that power supply makes a lot of noise when I sweep it, because it starts drawing current. That transformer's home. So if you hit this button, it's going to run a sweep. And it's going to plot a couple graphs over here. This first graph is a plot of the panel current and voltage versus the DAC output voltage, or yeah, the DAC setting. So X is the DAC, and then Y over here is current and voltage. And this JavaScript plotting routine called high charts, actually, as you hover over, you can see these points. The other thing this thing's pretty nice is that you can select a region of interest and zoom in and see the individual points on your graph. And as you hover over them, you can highlight the X and Y values. And down here I have this is the traditional IV curve for my panel. This is the IV curve itself. I have a fixed resistor in right now, so that's why it's a line. And then this over here is the power output. So if you hover over this, the power output is right around 8 volts. It's 13 ohms, or 13 watts. So that's working pretty well. And then if I'm going to come over here and see if I can do this. It requires a little coordination. So I'm going to sweep this thing. This guy up here is the panel voltage, and this is the panel current. And I have these cursors hooked up here. I can move them back and forth. So if I move this cursor over here and this one over here to kind of encapsulate the whole sweep, you can see up here that it sweeps this whole thing in 0.62 seconds. That's 500 data points it took in that time. One last thing is, let's see if I can do this. This is the light sensor here, the day sensor. We need this to know when the actual sun is up. So I'll put my finger on it, and we'll come over here and look at this data over here. And you can see that it's the day sensor value is about 1700. I'm going to take my finger off of it. It goes down to 200. So it's fairly responsive. Where this browser is actually using Angular timeouts to poll the status of the SolOhm board. So this thing's running like a champ. I have a lot more software to develop for the display, the IR interface. This is the one-wire interface to bring in all the temperature probes from the Dallas 18B20. I do have code. This is the real-time clock circuitry over here. I have code for the RTC to work right, so it'll be a data logger. This display also has an SD card right here. I'll have to implement SD FAT in the microprocessor. But this thing is running pretty well for today.